next category is content sharing. YouTube is a highly successful example of media sharing. Users upload their own videos for public viewing. Viewers can add comments to videos, tag videos with like or dislike attributes, and share videos with others. Many universities and professors have YouTube channels to which viewers can subscribe. These subscription-based channels allow newly posted video content to be easily seen when a user logs into YouTube. Distance education students could watch video on professor channels or post their own video on student channels, perhaps of a working motor control system that could then be viewed by the instructor and other students. While there are many application-specific collaboration tools, a good example of a general one is Google Docs. Google Docs allows documents to be edited in real time by multiple users. This can be easily adopted by teachers as a method for team-based problem solution and brainstorming. As a simple assessment strategy, instructors can assign colors to different students and require that all typed text by that student be in that color. Social networks use tagging mechanisms to locate and bring people together. The most famous social network is probably Facebook, but the example I've provided is LinkedIn, a network targeted for professional use rather than recreational or social use. LinkedIn is a social network. Like Facebook and MySpace, the goal of LinkedIn is to use tags and metadata to assist you in forming a network of connections. As people you contact agree to make a connection, your professional network grows. LinkedIn allows employers to advertise jobs, consultants to advertise service, and it also serves as a virtual Rolodex of communicating professionals. But there is also some real educational potential too. At MSOE, the computer engineering program has formed a group where students, alumni, and faculty can discuss topics in forum-style postings. This helps increase student autonomy as they interact with other practicing professionals, instead of relying on just the course instructor. Transactional distance is reduced when both alumni and instructors participate in the conversation. Of course, the challenge is seeding appropriate questions into the forum so that dialogue occurs. Left alone, the discussion could potentially turn to employment and benefits, rather than true learning about engineering. Finally, virtual worlds. The autonomous learning provided in simulations is well documented, and simulators are a common tool in education. However, the collaborative nature of virtual worlds, as well as gaming worlds, provide innovative and modern platforms for experiential learning. The challenge is the complexity of creating the world or the situational learning that occurs within it. This is an active area of educational research with many reports published in just the last couple of years. In any category, the challenge to instructors is integrating learning objects and their timelines into the environment and encouraging and assessing student participation. So let's move into planning how social media can enhance the educational experience. This slide gives good planning practices for all classroom activities. They apply equally well with social media. First, set a goal for the exercise. What will be the end result? On one hand, if it is a passive exercise, information is transferred from instructor to student in only one direction. As Michael Moore notes, this type of technology use limits the instructor-student dialogue. Still, a well-designed passive activity can guide a distance education learner and help to encourage student autonomy and enhance learning. On the other hand, if it is a collaborative, active exercise, students can feed back to the instructor or to other students. Collaboration certainly increases dialogue. Next, use a well-known learning taxonomy to choose the level of thinking that you want the student engaged in. Continue by choosing the educational model. Even though social media is highly collaborative, the biggest task for educators is developing new learning models that incorporate location-aware autonomy. Yet, even traditional and tested models can be used effectively. For example, spaced repetition, discovery through collaboration, and reflective practice can all be adapted to social media. Conclude planning by writing the activity and the social media timeline that will be used, if multiple event points are required. Finally, carefully monitor, assess, and perhaps participate in the activity. Absence of instructional authority may result in students receiving data or criticism that is unwarranted, especially if the type of social media used is open to the worldwide viewing public. Unwarranted criticism might downshift the student, decrease competence, and negatively affect their learning. I would like to spend the remaining time giving 2 example social media exercises. I thought they would be good examples for this discussion because, although they were created for a traditional university student population resident on the MSOE campus, they can indeed be used equally well with distance education learners. I chose traditional educational models that do not build location awareness into the exercise, so that the model should be familiar to most instructors. When I began planning the exercises, I used Bloom's taxonomy to choose the level of thinking. This taxonomy is well known in preparatory and collegiate education in the United States. Many instructors think about it subconsciously when writing their homework assignments, laboratories, and exams. Benjamin Bloom and his colleagues first published this taxonomy in the mid-1950s. The part of the taxonomy that we are most interested in is the cognitive part, the levels of thinking that we do when learning new material. At the bottom of the taxonomy is the knowledge level, verbatim memorization of material, known quantities, labels, identifiers, and values. As we move up the taxonomy, we reach comprehension. Restating the material in their own words is the goal at this level. At the application level, we're applying our lower level knowledge to practice problems, demonstrating the ability to solve them. The focus is on making connections. The analysis level requires the learner to decompose problems into parts, understand the logical flow, make statements about how each part relates to the others. The synthesis and evaluation levels are very high-level learning. The focus is independent and creative thought, leading to a final product and the ability to judge the product for success or failure. When using any new technology, and certainly social media, educators can use these levels of thinking to help guide the exercises so that they meet an educational goal. This example was designed to supplement and review topics taught in a first course in digital logic design at the Milwaukee School of Engineering. It uses the spaced repetition educational model to asynchronously feed students key points and tasks about digital logic design through the Twitter microblog service at regularly scheduled intervals. It differs from many applications of spaced repetition because it does not measure student competence in their learning through any feedback mechanism. Instead, it is designed to be a passive learning exercise where the social media tool is used only for content delivery and assignment suggestion. I do not enforce participation of students. Rather, their own self-motivation must increase their learning autonomy. One unique thing about the activity is the use of a social media timeline to climb up the levels of Bloom's taxonomy as the exercise progresses. Here is the social media timeline, the taxonomy level of each tweet, and the actual text message that's sent as the tweet. The instructor must post each tweet at some time on the shown day. Rather than using just one level of thinking, I increase the complexity as students move through the exercise. Some of the tweets reflect material learned in lecture, but by the end of the exercise, the tweets have moved past lecture content and instead encourage independent discovery of optimal design techniques. In many ways, this exercise is similar to the assignment of homework problems, but a key difference enabled by the social media is the asynchronous nature of tweet arrival, which hopefully encourages spontaneous thought and refreshes the cognitive learning loop of the student. Even though the student may be at work on something else, they may choose to ignore the tweet, they may delay processing the activity till later. In any case, the instructor has caused a momentary return to the course content and encouraged increased autonomy in the student by keeping the student working on extending the knowledge through higher level thinking. The second example was designed to supplement and review topics taught in a final course in embedded computer system design. Because it is the fourth course in the sequence, I considered the students to have near expert level domain knowledge. Thus, I chose a collaborative active exercise that would require them to work together to solve the problem. I still chose the Twitter microblog as the social media tool. This timeline shows how instructor activities and instructor tweets progress over the exercise period. Note that on many days, the instructor ignores any exercise activity and thus increases student autonomy through their own collaboration. On other days, instructor participation reduces transactional distance by correcting any obvious mistakes. These are the example tweets that have been created by the students during one instance of this exercise. Students are identified by number. S1 and S2 began a collaboration on day 1 that was then enhanced by student S3. As the instructor, my job was to monitor the student tweets according to the timeline, verify their concept map, and feedback corrections if needed. What I found is that corrections were rarely needed due to the knowledge base of the student. I do expect, however, that if I use this exercise in the first course in embedded systems, instructor dialogue might be more substantial. Here is the concept map that they had created already on day 3 of the exercise. It is well developed with categories, examples from categories, and connection arcs illustrating relationships. As the exercise continued, I had little work to do for the remaining days except watch and create their map periodically. I expect that if I use this exercise in the first course, again, instructor dialogue might be more substantial. I'll now return to my 3 key points to make summary comments. Transactional distance must be controlled in distance education. Any technological tool provides opportunities for both independent learning and instructor-guided learning objects. Social media can effectively be used to deliver learning objects to millennial students in a way that is familiar to them. Instructors can control instructor-student dialogue and the autonomy. But like any tool, appropriate planning of both the learning object and the exercise timeline is necessary to guarantee the success of the experience. 2 examples using Twitter, one of the simplest social media tools, were provided to illustrate how instructional models and timelining can be adapted. Thank you.